Let's say 24. So we want to evaluate the following in radical signs, right? So if there's no index, the index is 2 by default. The index 2. So what does this notation mean? This notation means this, let's say this equals to x. Then x squared is 121, right? That's what the radical signs mean here. For this one, this means a number raised by power 3 equals to 27 because the index is 3. Right. So the meaning of this A is means some number square equals to 121. Why do I put a 0 here? 121. I guess I didn't finish writing it. Right, someone square equals 121. So what's the square root mean? So which number squared to be 121? 11, right? So in this case, square root of 121 equals 11, because 11 times 11 is 121. For this one is a fraction, all under square root. We can split into the numerator 36 being square root, oops, sorry, and the denominator 25 is being square root. So we can split into 2 radicals, numerator with a radical, denominator with a radical. Now, square root of 36 is a 6, because 6 squared is 36. Square root of 25 is a 5, because 5 squared is 25. So similarly for this one, C, x equals to 3, because 3 raised by 3 is 27. 3 raised by 3 means 3 times 3 times 3. 3 times 3, 9. 9 times 3 is 27. For D, we have a negative, right? So negative number raised by 3 will be negative. So cubic root is the same thing. Means a negative number to the power 3 equals to negative 1 over 25. Only think about this number 125. We know 5 raised by 3 is 125. So this is a negative 1/5. Right? When we raise by 3, negative raised by 3 is still negative. 1 raised by 3 still 1. 5 raised by 3, 125. For E, it's a little bit tricky. Okay. E, we have parentheses around this -7. So what do? We first square the negative sign, which you get a positive 7 squared. So then, because of negative, think about -7 can be split into -1 times 7. When we square -1, means -1 times -1 become +1. So get 7 for this one. But this one, F, is a -9 squared, right? This square has nothing to do with the negative sign because we don't have parentheses around -9. That means this square only apply to number 9. So we get -49. I mean 81. Right, 9 squared is 81. So we get square root of -81. If this were before we learned complex numbers, we know this has no solution in real number system, right? We would say no solution in real number system. But now, since last week, we have learned imaginary numbers, complex numbers. So now we know this can be written as 9i. Again, if this question were asked under real numbers, there's no solution. There's no number. You raise, you get to negative. But with imaginary number, we can do that. So in imaginary number, I equals to square root of -1. So square root of -81, we can split into square root of -1 times square root of 81. Square root of -1 is I in complex number. Square root of 81 is 9. So we can write I before 9 or after 9. Doesn't really matter. Okay, that's this question. Now let's see the next one. Oh, we still have 2 more. G. We have a -6 root. So this negative sign has nothing to do with this 6 root of 64. So what do? We just inherit. We just carry on with us. Then we have 6 root of 64. Remember, 64 can be written as 2 raised by 6. 2 raised by 5 is 32. 2 raised by 4 is 16. 2 raised by 6 is 32 times 2, which is 64. So when the power of 2 is the same as the index, right? The power of 2 is 6. The index is also 6. 6 over 6 is 1. So we just get -2. Just be careful with this negative sign. All right. Let's see H. Now first, then we have a negative outside the 5th root. So we just carry on with us. 5th root is odd number, and the power of 5 is odd number. That means we could have a negative radicand. Okay, inside the radical signs, we call radicand. Radicand. And if the index is odd, the power is odd, so we allow the radicand to be negative. So in this case, we just get a negative 23. Negative times negative become positive, so get a positive 23. Now let's see 25. Find the domain of those radical functions. Right. So this one index is even, is 2 by default. So first we want to find the domain, then we want to evaluate at a given x value. Okay, so we have to do 2 things. So remember, how do we find the domain of a radical function? If the index is even, we take the radicand out. So in this case, we take 6 minus 2x out. We say this one has to be greater than or equal to 0, which means at least 0. Cannot be negative. Because when we talk about functions at this level of mathematics, we talk about functions only taking real numbers as its domain. Okay. So we don't talk about complex numbers, imaginary numbers for functions yet, in this case, in our study. So we just solve this inequality. Solve this inequality. We have moved -6 to the other side. We get -2x greater than or equal to -6. Now we want to divide both sides by -2. When we do that, -2x divided by -2, we get a 1x. But we don't bother to write a 1 in front of x. We just write it as x. But when we multiply by negative number on the both sides of the inequality, we have to switch the inequality sign. So now from greater than or equal to becomes less than or equal to. Or -6 divided by -2, that's just 3. So that's its domain. But maybe sometimes we ask to use interval notation to represent. Remember, less than going to the left, right? We're going to the left. Always imagine 0 sits in the middle. To the left goes to, in the end goes to where? negative infinity, right? To the right goes to positive infinity. So this means x is less than or equal to 3. So 3 is somewhere. 3 until in negative infinity. But we write the intervals from the smallest number to the bigger number. So we will start writing negative infinity with open parentheses, not with a bracket, because infinity is not concept, it's not idea, right? It's not idea, it's not a specific number. Then up to 3. Because we have equal sign in the inequality, so we would use a bracket to indicate, okay, 3 is in the domain. Now we want to evaluate f of negative 5, x at equals negative 5. So we write as f of negative 5. Or in the beginning, if you want to get used to it, you can write like this, f of x equals to negative 5. Okay, but normally we should write f of negative 5. So what do we do? How do we evaluate when x equals to negative 5? We just substitute x with negative 5. So we get square root of 6 minus 2 times negative 5. Right, then we square root. So square root of 6. 6 is constant. Minus 2. Minus 2 is a scalar. The only x is a variable, right? X is variable now. X is given as negative 5. So we just substitute x with negative 5. Now we just evaluate. So we get a square root of 6 plus 10. Negative 2 times negative 5 become plus. 6 plus 10, 16. Square root of 16, that's 4. So for question A, the domain is going from negative infinity up to 3, including 3. And evaluation of f of negative 5 is 4. I'm going to erase this so I can have more spot, more empty space to write on. So B. B is very similar to A. The index is still 2. So the even number, if it's an even number, the radicand has to be non-negative. Non-negative in mathematics means greater than or equal to 0. Right? So when this index is even, if it's a 2, 4, 6, even number, we take the radicand, we set to greater than or equal to 0. Then we solve for the inequality. And that's easy, right? Move negative a to the other side, it becomes positive a. So x greater than or equal to 8. Now we want to evaluate at x equals to 9. So which is f of 9 equals to, we'll just plug in square root of 9 minus 8. Let me add square root in with my pencil. For 9 minus 8 is 1. Square root of 1 just 1. So f of 9 equals to 1. C. C is a little different from 1 and 2 because the index. Now the index is odd. If the index is odd, radicand, and also is a numerator, it's not in the denominator, then the radicand takes all real numbers. So it can be all real numbers. So in this case, what do we mean all real numbers? The domain is all real numbers. We indicate with, from negative infinity up to positive infinity. Basically means any real numbers. The x equals negative 7, we want to find f of negative 7. We do the same thing. So we have cubic root of 6 minus 3 times negative 7. Just plug in, right, the value given. So remember this is a cubic root. Cubic root of value index, we write 3 on the top of corner here. -3 times -7, that's positive 21. 6 plus 21, that's 27. Or cubic root of 27, remember we have calculated once in previous question. Hope you can remember it. Yes, it's a 3. Because 3 raised by 3 is 27. D, the index is even again. So we take the radicand. Let's see, 6x plus 3 has to be non-negative. 6x plus 3 has to be greater than or equal to 0, which means at least 0. So we solve, we move 3 to the other side, becomes a -3. We divide by 2, we divide by 6 on both sides, so x is greater than or equal to -½ So I make greater than, right, or equal to, including -2. So greater than to the right to where? To positive infinity, close parentheses. We never use bracket for infinity sign. Okay, infinity sign is just a concept. It's not a specific number. 26, simplify it. Let me move up a little bit. So 26, we want to simplify, include absolute value signs where necessary. All right, let's see. So the index is 2. That means whatever comes out has to be positive, not negative. And we see this one can be, the inside is perfect square. It's x minus 3 squared. Oops. X minus 3 squared, then square root. Square cancels the square root. So we get x minus, this is x minus 3. But because the index is even, so the radicand cannot be negative. So how do we represent the radicand cannot be negative? We put an absolute value bar around it. So equals x minus 3, but we force it to be non-negative. Right? So this is in real number world. Now let's see B. B, the negative sign is not inside or involved with the radical expression. So we just carry on. Then we have square root. If you recognize the inside, that's x plus 2 squared, a perfect square. Remember the perfect square formula? You square the first one, x, you get x squared, right? You square the last one, 2 squared is 4. How do you check the middle term? The middle term comes from 2 times x, x times 2. We'll multiply those two, x with 2, that's 2x. Then double it, 2 times 2x, that's 4x. Then we square root. Square root cancel with each other. We carry on the negative sign with us. And we want to force x plus 2 to be non-negative. So we put the absolute value sign around x plus 2. So B, answer is negative, absolute value, x plus 2, absolute value bar. Let's see 5. 5, if we remember, 243 is a 5, is a 3 raised by 5, right? 3 raised by 4 is 81. 81 times 3, that's 243. So 3 raised by 5 is 243. Because the index is odd number, so we can take negative value as a radicand. So in this case, we get a negative and 3, because 3 raised by 5, then 5th root, the index and the power are the same. It becomes 1. So 3 raised by 1, we don't worry to write 1. This is by default. We read nothing there. Then we have y. Y to the fifth, then fifth root, 5 over 5 becomes 1. So we just have y. Do we need to force this y to be non-negative? No, because the power is odd, the index is odd. Okay, negative 3y is the answer for C. Let's say D. X plus 3 raised by 4. Perfect, because the index is 4. We just need to force x plus 3 to be non-negative. We just want to force x plus 3 to be non-negative because the power is even number and the index is even number. We'll put the absolute value bar around it to force it to be non-negative. Now what about 625? 625, I'm guessing is a 5 raised by 4. Because 5 squared is 25. 25 times 25 is 625. So we have 5. 5 absolute value of x plus 3. Let's see next bunch, 27. After 27, I'm going to take a little break because my fingers really, this writing pad really hurts my fingers. Okay. 64 raised by a rational exponent, 2 over 3. So what does this mean in radical forms? That means the index is 3 and the power of 64 is 2. So 64 raised by 2. So you see this rational exponents. The numerator indicates the power. The denominator in the exponent means the index. Okay, so what do we want to do? But actually, when we do calculations, we want to keep this form. All right, we'll keep that form. We want to rewrite 64. Remember, 64 is 4 raised by 3, right? Let's write as 4 raised by 3, or 2 raised by 6. But in this case, we would rather write 4 raised by 3 because the index is 3. So 4 raised by 3, then square, because 64 square, then cubic root. We have 2 layers of exponents. We multiply them. So that becomes 4 raised by 6. Then cubic root. Right? Oh, we don't really have to do this, right? Or we could do this. Then we can rewrite as rational exponents. The power is the numerator. The index is the denominator. Or 6 divided by 3, that's 2. So that's 4 squared, which is 16. The second one with negative index. Right? How do we write this one? Negative exponent means it's 1 over, well, then we have square root, because the rational exponent denominator is 2, right? Square root of then this raised by 3. What's square root of 25? Which is 5. 5 raised by 3, 125. So then 1 over 125. Right. Well, another way we could do it is from the very beginning, we rewrite 25 as 5 squared. Then 5 squared being raised by negative 3 halves. We have 2 layers of exponents. What do we do with the 2 layers of exponents? We multiply them. So I have 5 raised by 2 times negative 3 over 2. 2 is positive. Negative 3 over 2 is negative. So we will get 5 raised by a negative number. So multiply those two. Then 2 cancels these 2. So we get negative 3. So 5 raised by negative 3. What's 5 raised by negative 3? It's 1 over 5 raised by 3. And it is exactly 1 over 125. So, you know, there are always different ways to solve a specific question or evaluate or do, you know, anything, the different ways of doing it. You just pick one you feel comfortable with, okay? Let's see C. C, we have two bases, right? This no operations means multiplication. We have x raised by 2 over 7. Then multiply by x raised by 4 over 7. With same base, multiplication indicates adding the exponent. So x raised by 2 over 7 plus 4 over 7, which is x raised by 2 plus 4, 6, denominator 7. If we want to write as radical form, we will write 7th root of 7th root, yeah, of x raised by 6. D. D, we see 64 can be written as a squared, right? A squared is 64. Now we want to distribute this exponent. Remember 2 layers of exponents, we multiply the 2 exponents. So we multiply the exponent of 8, which is 2 with a half. We multiply those 2 first. What do we get? We get 2 times half, that's just 1. So we just get 8. 8 raised by 1, or just 8. Then what about x term? X term, the power becomes 6 times half. 6 times half, which is 3. Then y cube. Y cube times, so 3 times half, that's 3 halves. That's y. 3 halves is 7 over 2. Well, 7 is bigger than over 2. 7 is bigger than 2. So we rewrite it as ax cubed. And 7 we want to split into 6 plus 1. Then we have y raised by 3. Then y raised by half. Well, what's y raised by half? Square root of y. So this is the answer for which one? For 86. For this one, for D. For 64, this one. Okay, now let's look at the E and F. As you can tell, I'm already feeling a little bit tired, so I'm gonna do E and F and take a little break. So E. E will have choice. We have X, Y, Z, and Y is raised by negative exponent. So we have choice. Let's just move the next exponent of Y to the denominator, which is truly where it belongs. So now Y raised by 3 over 5. You see Y raised by positive 3 over 5. Right? No more in the numerator, in the denominator now. Now every exponent is positive. So let's distribute 3 to every exponent. Right? We distribute to every exponent. So the numerator we get, well, x raised by 4 over 5, now times 3, that becomes x raised by 12 over 5. Right? Because 3 times 4, that's 12. Then divided by, in the denominator, we have z raised by 2 over 5 times 3. Now it becomes z raised by 6 over 5. For y term, y raised by 3 over 5. Now multiply by 3, that's 9 over 5. We see all those 3 variables raised by some power, and then with a 5, which is index, right? Because 5 appears in the denominator. So we can write like this. They're always index 5. So then we have x to the 12th power divided by z to the 6th power and y to the 9th power. And we can simplify this a little bit because the exponent of x and the y are bigger than the index. So this is x raised by 12. We can split x raised by 10 and x raised by 2. Then x raised by 10, then with the 5th root becomes x squared. Because 10 divided by 5 is 2. Then inside, we still have x squared left because 12 is 10 times 10 plus 2, right? Then, of course, this index is 5. And the denominator, so we have z to the 6th. Now, this is z. And also another z. So z to the 5th, then 5th root, just becomes z to the 4th power. But we still have another z inside, under the 5th root. And the y to the 9th can be split into y to the 5 plus 4. Right? So we still have 5th power of z times y raised by 4. Raised by 4. Z. Oh, hold on a second. So we have zy, right? Because y raised by 9, right? Then y can split into y raised by 5 and y raised by 4. Now y raised by 5 with the 5th root becomes y, becomes this one. Now I have z and y raised by 4 inside. So the answer is this. And if we want, we can write the radicals, the radicand and one radical. So x over zy, 5th root of x squared divided by z times y raised by 4. So this is the answer for E. Let's see F. F, we have this one to be negative, right? The outside power to be negative. So that means inside we don't have negative exponents. So what do? We just flip the numerator and denominator. Right? Flip the numerator and denominator. Get rid of this negative sign. Now y raised by 3 over 4 becomes the numerator. Then raised by 1/3 again. So 3/4. Think about 3/4 times 1/3. That's just 1/4. Because 3 over 3 becomes 1. So in the numerator, we have y raised by 1/4. What's 1/4? That's the 4th root of y. The numerator, the denominator now is 2x raised by 3. Then raised by 1/3 again. So we still have, so 1/3 is cubic root. We still have 2 inside, but do you see x come out? Right? So let's write x up front. So we deal with the negative sign first. Flip, well, how do we deal with the negative sign? Flip the numerator and denominator. Y raised by 3 over 4 become the numerator now. Then raised by 1/3 again. So we multiply 3/4 and 1/3. We get y raised by 1/4, which is the 4th root of y. Then 2x cubed becomes denominator now. So 2x cubed now raised by 1/3 again. So 2 raised by 1/3 is the cubic root of 2. Right? X cubed raised by 1/3. So I have 3 times 1/3 is just 1. So we just get x. Right? We just get x. So we have cubic root. We have a cubic root with x. So that's our final answer. The numerator will have fourth root of y, the denominator will have x times cubic root of 2. Or you can write a cubic root of 2 times x. Okay, now I'm going to take a little break. Then hopefully I still